Short-run cost curves are one of the most tested topics in economics. Yet this is where many students lose marks. In this lesson, we will derive the curves, explain their shapes, and focus on exactly what examiners expect. In the previous video, we focused on total fixed cost, total variable cost, and total cost. In this video, we move one step further to average fixed cost, average variable cost, average total cost, and marginal cost. We will derive all these new curves from the same short-run cost table we used in the previous video. So here's exactly what we will do today. First, we will understand the average cost curves, AFC, AVC, and ATC, their formulas, their shapes, and the reasons examiners look for. Then we will focus on marginal cost, how it is calculated, and its behavior in relation to AVC and ATC. In the short run, firms look at average costs, the cost per unit of output. There are three average cost curves you must know: average fixed cost, average variable cost, and average cost, also called as average total cost. We will derive each one directly from the same table we used in the previous video. Let's start with average fixed cost. Average fixed cost is the fixed cost per unit of output. It is calculated as total fixed cost divided by output. Total fixed cost remains constant at all levels of output. It is constant at all levels of output. When output increases, the same fixed cost is spread over more units. As a result, average fixed cost curve keeps falling. Remember this, that the AFC curve slopes downwards because AFC falls with increase in output. There are some special things about this curve you need to remember. AFC curve is an asymptotic curve, which means that AFC curve can never touch the x-axis, as TFC can never be zero. Even at zero level of output, you will have some TFC. Also, it can never touch the y-axis because at zero level of output, TFC is a positive value, and any positive value divided by zero will be an infinite value. Another important thing about this curve is that it is a rectangular hyperbola. Rectangular hyperbola is a curve in which any rectangle formed under this curve, any rectangle will have the same area. Area under AFC curve will remain same at different points. So these are some special things you need to remember about average fixed cost. Average variable cost is the variable cost per unit of output. In the short run, variable costs change with output. So AVC tells us how much it costs on average to produce 1 unit. We ignore fixed cost here. The formula is simple. AVC equals total variable cost divided by output. Let's now derive the AVC curve from the cost table. At zero output, AVC is not defined because no variable cost is incurred. AVC initially falls with increase in output, and after reaching its minimum level of 5 here, it starts rising. This is why the AVC curve is U-shaped. It is due to the application of law of variable proportions. Initially, AVC curve falls due to increasing returns to a factor with better utilization of fixed and variable factors. After reaching its minimum level, AVC starts increasing with every increase in output due to diminishing returns to a factor. Remember, whenever you explain AVC or MC, you should always link the shape to the law of variable proportions. Average total cost tells us the total cost per unit of output. In the short run, total cost has two parts, fixed cost and variable cost. So ATC is also defined as the sum of average fixed cost and average variable cost. There are actually two ways to calculate ATC. One is ATC equals AFC plus AVC. Another way to calculate the same thing is that if you divide total cost by output, you again get the cost per unit. Both formulas give the same ATC and examiners accept either as long as it is written correctly. Now let's derive the ATC curve from the cost table. For each level of output, we divide total cost by quantity produced to calculate ATC. Plot these ATC values against output and we get this curve. Notice the shape. The ATC curve is also U-shaped because initially the fall in AFC and later the rise in AVC dominates. Let me explain this by bringing all the three curves together in one graph. If you notice here, in the beginning, when we are moving from 1 unit to 2 units, your AFC is going down, AVC is also going down. Therefore, both are falling, so AC curve is also falling in the beginning. After that, when we move from 2 units to 3 units, your AFC continues to fall, but AVC has become constant. Here, that is why we say that in the beginning, AFC is dominating. The fall in AFC is more prominent in the shape of ATC curve. After that, if you notice, when we move from 3 units to 4 units, your fall in AFC and your rise in AVC are both equal. So AC has become constant. And then when we move from 4 units to 5 units, the AFC continues to fall, but the rise in AVC is more than the fall in AFC. So on this side of the AC curve, the role of AVC is more prominent than your AFC. This is why your ATC curve is U-shaped. There are few more important observations about these three curves which are regularly tested in exams. If you see, your AC curves or ATC curve will always lie above the AVC curve because AC at all levels of output will include both AVC and AFC. Also notice that AVC reaches its minimum point at a level of output lower than that of ATC because when AVC is at its minimum point, AC is still falling because of falling AFC. As the output increases, you will also notice that this gap between AVC and ATC, this one, it decreases. This gap will decrease, but they never intersect each other. This happens because the vertical distance between them is actually AFC, and which you know can never be 0. Remember that this relationship between AFC, AVC and ATC, this is extremely important and this is where you will find lot of questions being asked. So prepare this very thoroughly. Marginal cost is another important cost you should know well. Marginal cost tells us how much total cost increases when we produce one extra unit of output. Marginal cost is not averaging. We are asking a change question here. That is why marginal cost is calculated as change in total cost divided by change in output. When output increases only by 1 unit, marginal cost is simply the difference between two successive total costs. So you can use any of these methods to find out marginal cost in your numericals. Now let's derive the marginal cost values step by step from the total cost table. Now when output rises from 0 to 1, total cost rises from 12 to 18. So marginal cost is your change in total cost divided by change in output, which is coming to 6 units here. Then 4, then 5. Notice what is happening. Marginal cost falls at first, then it starts rising. This also gives us a U-shaped marginal cost curve. The reason for this U-shape is also the law of variable proportions. Initially, better use of the fixed factor increases productivity, so marginal cost falls. But beyond a point, adding more variable factors lead to overcrowding and inefficiency, so marginal cost rises. This explanation of law of variable proportions is essential. Without it, a correct diagram alone does not earn full marks. Also, you have to remember another important point. As we know that fixed cost does not change with output in the short run, so when we calculate marginal cost, the entire change in total cost actually comes only from variable cost. That is why marginal cost depends only on variable cost. Therefore, we can also use this formula to calculate MC. Now comes a very important relationship that examiners love to test. We are going to understand the relationship between MC, AVC, and ATC together. Now, if you look at the table, first let's draw the graphs. This is how your graphs will be. So now if you look at the table, what is happening? When your MC curve is below ATC curve, what do you observe? That MC values are lower than AC values. So here MC curve is below ATC curve. That time your AC curve, ATC curve is also falling. At 4 units of output, AC and MC are equal. That is where they intersect each other at 4 units. And after that, when your MC is higher than ATC, you will notice that ATC also starts rising. Now, this relationship is also important between MC and ATC. So what happens when your marginal cost is below average cost, your average cost is actually falling. And when marginal cost is above your ATC curve, average cost is rising. Also notice that marginal cost cuts both AVC and ATC at their minimum points. I know that there are so many points you need to remember about all the curves we discussed today. But believe me, these are very important points and you will be tested definitely. Now let's do a full cost table practice, exactly the type examiners love to test you on. Look at the table. We have Q, TFC, TVC, TC, MC, AFC, AVC and ATC. Some values are given to us and our job is to fill in the blanks logically using the formulas we already learned. Now start with what you know. First, let's look at the table and circle the values. Notice you have been given at 4 units of output, TFC is 60. Now this value is super important because total fixed cost stays constant at all output levels. So I can immediately write TFC is equal to 60 for all the units. After that, if you notice at Q is equal to 0, we see MC, AFC, AVC, ATC are shown as dash. Correct, because we can't divide by 0 output. But remember, at Q is equal to 0, TVC is also 0. This is also something you need to remember. Next, we know the formula TC is equal to TVC plus TFC. So it means I can find TVC wherever TC is given. So TVC would be TC minus TFC. So in this case, for 2 units of output, it would be 100 minus 60 is equal to 40 and so on. Now TC becomes easy to calculate. Great. I can put TC as sum of TFC and plus TVC. We get all the values for TC. After this, we will calculate MC using change in TC by change in Q formula. Now we know that here Q is increasing only by 1 unit. So MC is simply the difference between two successive total cost units. So at Q is equal to 1, it would be 80 minus 60, which is 20, and so on. I hope this is clear. Now we will calculate all the three averages, AFC, AVC, ATC. These are all per unit costs. AFC is TFC by Q. Since TFC is constant, your AFC is going to decline. It is going to fall. It is going to go down. It will keep falling as Q rises. Then you have AVC is equal to TVC divided by Q. So use the TVC values we just found and we get these answers. Then when we look at ATC, it is nothing but TC divided by Q, or you can also cross check using ATC is equal to AFC plus AVC. This is a great way to avoid any type of silly mistakes. I hope that you have understood all the formulas and how to apply them. Again, you are usually tested on some of these parts of the table, definitely. I know that it is a lot to remember. To make it easier and recap, the next step is applying them in board level questions. In the next video, I will solve actual past year questions step by step, exactly the way examiners expect. If you would like help mastering definitions, diagrams, or full exam strategy, check out other videos on my channel, and you can always reach out to me for any help. See you soon.